Hello and thanks for watching. In this video we're going to start our probability journey. So jumping right in, let's start with some sets. So a set is set. This is just a list of elements packed into like one group. So for example we mark these sets using curly braces and we say like 1, 2, 3 is a set. So these elements, our elements are 1, 2 and 3, and this is the same as a set 3, 2 and 1 because our elements are still the same. This is also the same as a set 1, 1, 2, 3. These are all equal because they have the same elements. Okay, now we can also define our sets a little bit differently. So we can define a set to be some element such that we have some condition on our element. So for example, if we have this set such that x is a natural number, for example, this is the set of all natural numbers, so we have -1 in the set, oh no, not -1, we have 1 in the set, we have 7 in the set, we have 11 in the set, we have 385 in the set. We have all these numbers in the set, as long as they're an integer and they're positive. So now we're going to define some loosely stated operations on sets. So firstly, if we have sets, some set A equal to 1, 2 and 3, and some set B equal to 2, 4 and 6. Okay, so we define the union as a big cup here, A union B equal to all the elements put together. So we have 1, we have 2 in both, we have 3, we have 4 and we have 6. So a little bit more formally, even though it's still not quite formal, if we have A union B, this is loosely defined as an element x such that we have x in A or we have x in B. So this is basically saying that this element is either in A or in B. It can be in both as well. So next, using the same A and B, we define the intersection. So we have A with like a cap this time. So A intersect B is equal to just 2. So what I did here is I took all the shared elements of the set. So for example, 1 is not in this set because it only appears in A. 2 is in this set because it appears in both A and B. 3 is not in this set because it only appears in A, and so forth. So a little bit more formally, we define this to be equal to some element x such that, or the set of elements such that this element is in A and it is in B. Okay, and now one more thing, we say that A excludes B if we have X such that X is in A, but then X is not in B. The viewer may want to try to pause the video and try to write down the set A excluding B with just this definition. Okay, so which elements are in A such that they're not in B? So 1 is in A, it's not in B, so we're good to write down 1. 2 is in A, but 2 is also in B, so we don't want this. 3 is in A, but it's not, and it's not in B, so we have this. Okay, so now we're going to define what a subset is. A subset, we say A is a subset, this is the symbol for a subset, of B if for every element X we have X in A, implying that X is in B, but this is only one way, so we could have some set such as 1, 2, 4, and then 1, 2, 3, 4. Now A is a subset of B because every element in A is also an element in B. However, B is not a subset of A because there exists an element which is not in A. Note that if we say that we have this subset, this means that that A has the same amount of elements or equal to B. However, if we say that A is a strict subset of B, this means that A must have less elements. Proper subset, strict, proper. Okay. So now I'll introduce a very important set. We have this set, and we call it the empty set. This empty set is just defined as an empty set. So we say that the empty set is a subset of any set for all sets. And clearly this is because if we have nothing in the set, then clearly it is still going to be a subset. If we remove all elements, then we're left with the empty set. And ultimately we're going to define what the power set is. The power set of a set is defined to be a set B such that B is a subset of A. So for example, if we take the set, this small set, I'll make it small because this power set gets really large really quickly. So the power set of this is this empty set, and then we have 1, and then we have 2, and then we have 1 and 2, and this is the power set. So if we have A equals this, we have the power set of A equal to this. This is every subset we can take of A. Okay, so that's all I'm going to teach in this video. Now I'm going to leave some exercises for the viewer So exercise, oops. So the first one is going to be, let A equal this, and B equal to find A excluding B, A intersection B, and A union B. And then as a second exercise, as a small challenge exercise marked with a star, we'll say let this denote the number of elements in a set. Prove that the power set, that the cardinality of the power set is equal to 2 to the power of this. Yes, that's the end of the video. Thanks for watching. Hopefully you learned something or helped to consolidate some knowledge. Bye bye.